Students, in the last class, I think I could not give you the proper video. So I would like to take the class again, the class on association. You know, what is association? Let us look at this picture. So what is the speciality of this picture? Hmm? When the values of x is increasing, that is 40 to 60, 60 to 80, 80 to 100, 120, 140, etc., then the value of y also increasing. Okay, so that means there is association between x and y. Look at this figure. The association may be positive, this is positive association, this is negative or non-linear, etc. So this is this shows some implications of association. This is positive association, this is negative association, no association, etc. Okay, so we can think about this association in reliability context. Okay, suppose you are you are considering a three-phase line. Okay, electric line. What is the speciality of three-phase line? If at least one of the electric line is working, then the sufficient electricity can be provided to the customers. Okay, so this is the this is a typical three-phase line, and one among these four lines would be neutral, and three lines would be what is that, having electricity. So think about the situation that that of a rainy season. So sometimes we may face the situation that if any one of the line is what is that switched off, then what happens? The load towards the remaining lines will be increasing. Okay, so automatically within hours the second line will also be in failed state, and third line also will be going to failed stage. So there is a complete failure of electricity. So that is happening in our daily life situations. Okay, so what is this what is the reason for failing the remaining two lines when one of the line is in failed state? So that is because of the load to the remaining lines will be increasing. So this type of load sharing system, so you can think about the load sharing system, and in that case there is a association between these three lines, life of these three lines. If the life of the first line is going to zero, or going to what is that, if first line is failed, then normally the remaining line will be going to fail soon. Okay, so that is the situation. That is the situation I have mentioned in the last class. Another situation is, you can think about the what is that, computer lab. What is the specialty of computer lab? What is the specialty of computer lab? You can see several computers are working here, and there will be some general UPS or general batteries providing sufficient power supply for these computers. Okay, there may be 4 or 6 number power generation batteries, and using that battery we can work at least 16 or 20 computers at a time. Suppose if any one of or any two of the batteries are failed, so what happens? Still we can continue with the lab activity, because if 6 batteries are available, and if 2 of them are failed, we can work the lab with the remaining 4 number of batteries. Okay, so in that situation you can see that the load to the batteries will be increasing, because instead of 6 batteries, the lab is working with 4 batteries. So the load to the power supply has to be given to all the computers, so that the load of the batteries, the remaining batteries, will be increasing, and as a consequence, the remaining battery will be going to fail in very near future. Okay, so that is because of so that is the concept of that is the motivation of discussing the concept of association. Okay. I think I have given the pages of the textbook we have discussing, and in that book they are giving that examples. What are the examples? Either load sharing system, or we are considering this type of power supplies, or and another situation is given in that text, that is the components, the system having same uh, set of what is it? I will give you same set of minimal path sets. Okay, the minimal path structures of coherent system having components. Okay, so sometimes we can see that in several minimal paths we will have components in common. So that is a situation of what is that? Uh, Sharing the same component to the different minimal paths. Okay. Another example is components subject to same set of stresses. Suppose same set of stresses are applying to the some components. So the components may be showing a behavior of failing soon. Okay, so in that situation we can say that there is some association between the components. At the same time, you can think about the independence of that components also. Okay, if in rainy season we can see that if the what is that, if electricity is increasing, if due to any jerking or due to any what is that, unexpected events, if the electricity or voltage is increasing, what happens? We may be facing the situation that our fridge may be in fail state, going to fail state, or TV may be going to fail state, or computer may be going to fail state, so etc. So they are facing same stress. Okay, so in that case you can think, you can see that fridge is independent of what is TV is independent of our computer, everything is independent. At the same time, if they face high voltage, they will tend to fail. Okay, so that is the situation of what is that, components subject to same set of stresses. Another, structures in which components have share load, that we have discussed in the beginning. Okay, so that the failure of the one component is what is result in increased load on each of the remaining components, like in computer lab, or in the case of three-phase line, etc. Okay, so in the components are associated, at the same time they are independent. So let us draft a theory for this association, this concept of association, that is done by SRI, Prosen and Wacker. Okay, this is, I think this is a paper published in 1967. So at that time also they are considering this type of problems. Okay, so what is association? How can we measure the association? Okay, that is the problem. How can we measure the association? I think we have discussed the correlation. This is actually a positive correlation. So we can use Karl Pearson correlation coefficient as a measure of association. Okay, or we can use any other correlation measure for measuring the association, degree of association. So to assess the degree of association, either we can use correlation or we can use covariance. So if covariance is positive, correlation will be also positive. Negative, the correlation will be also negative. So we can take the covariance only. So from that we will get other measures. Okay. So what is covariance? So we can treat covariance of two lifetime random variable as a measure of association. Okay. So covariance of S comma T. Okay. What is covariance of S comma T? Expectation of ST minus expectation of S expectation of T. If it is positive, greater than or equal to 0, then we can say that the components, the lifetime of components are associated. Suppose S is the life of fridge and T is the life of TV. So they are independent, at the same time they are associated. If covariance of S comma T is greater than or equal to 0, then we can say that they are associated. This association may be due to any other external stress or external load or external voltage increase or current increase, etc. Okay, so we can measure the association, the type of association, that is whether it is positive or negative, based on this covariance measure. Okay, so this is the covariance. So covariance can be considered as a measure of association, or to identify the sign of association. If a more strong definition is if f of s and g of t are the functions of s and t, then if covariance of f of s comma g of t greater than or equal to 0 for all pairs of non-decreasing functions f and g, then s and t are more strongly associated. And furthermore, strong association concept is given by covariance of f of s comma t comma g of s comma t greater than or equal to 0. Still it is more, we can measure strong association. Okay, so it is still more strongly associated. So if there are n number of variables t1 t2 etc tn, okay, so what is covariance of what is the measure of association? Covariance of f of t comma g of t greater than or 0. If it is greater than 0, we can say that the vector t1 t2 etc tn is associated. So these are the definitions they have given based on the fundamental idea of this one, this figure, and fundamental idea of load sharing system. Okay. Hello. Hello. പറയും പെട്ടെന്ന്. ആണോ? ഓക്കെ ഓക്കെ, അപ്പം ഞാൻ വണ്ടി മറ്റന്നാൾ പറ്റും. മറ്റന്നാൾ ഓക്കെ 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 ഓ അല്ല, 2 മുതൽ 7 വരെയുള്ള ദിവസങ്ങളിലാണ് ഉദ്ദേശിച്ചതെന്ന് കേട്ടോ. ആ, ഞായറാഴ്ച മിക്കവാറും ഞാൻ വിളിക്കും. നാളെ തന്നെ അറിയിക്കാം, നാളെ അറിയിക്കാം കേട്ടോ. ഇല്ലില്ല, ഇപ്പം ഈ ലിസ്റ്റിലുള്ളവർ വന്നാൽ മതി കേട്ടോ. ആ ഓക്കെ ഓക്കെ ശരി. ഓക്കെ, അപ്പോൾ അതാണ്. അപ്പോൾ അത് നിങ്ങളത് മനസ്സിലാക്കുക. So another okay, so there are plenty of properties available for measuring regarding the association. One is any subset of associated random variables are associated. We are not going in detail, but just remember that these are the fundamental properties of association. Another is if two sets of associated random variables are independent of each other, then their union is a set of associated random variables. S1, S2, etc. Xn are associated and T1, T2, etc. Tm are associated, then their union is also still associated. Another example is the set consisting of a single random variable is associated. Another is non-decreasing functions of associated random variables are associated. Okay, you know, our coherent system is a non-decreasing or increasing function. So coherent systems will be associated if the components are associated. Okay, so that is the application of this association in reliability. So independent random variables are associated. Okay, so this is another definition. You can just go through these definitions and properties only. No need to go in detail about the what is that proof. You are not study you are not supposed to study the proof of these results. Just know this is the vector component. Just know the concept of association only. Okay. My research work is also uh, also included uh, the some concept of association, and we have proposed some association measures in terms of transition probability matrix function of a stochastic process. Okay, so that you will study in PG classes. You don't know, you cannot understand the concept if we discuss that results here. So this is another property. If x1, x2, xn are associated random variables, then 1 minus x1, 1 minus x2, etc. 1 minus xn are associated binary random variables. Okay, this is another result. So we will use all these results in our reliability analysis. For what is the role of this concept of association reliability analysis? That is to find out the bounds for the reliabilities. So that is the use of association in reliability analysis, to find the lower and upper bound for the reliability of series system and parallel system. We can use this association concept. Okay, so that we will discuss in the next class too. Okay. Okay, the വേറൊരു result ആണ്. You can this is further strong results. Okay, anyway, you don't need to go through all these proofs. You just read the results and try to understand the concept of association. Okay, so this much is given in this paper, and as I mentioned, we have conducted the association in stochastic process, and I will show you that paper to you. You can see, and you can understand the concept at the same time. We have done some results, and it is published in International Journal of Statistics and Applications. This work was with my research guide, Dr. M. Manoharan, Professor of Department of Statistics, University of Calicut. Actually, it was published, it was accepted by this journal in this year, and it will be online in 2021. Number 2 means it will be almost in June 2021. It will appear in that journal in June 2021. So actually it is accepted, revised and accepted. Okay, so the content of this paper is on association of time of Markov process with application to reliability and survival analysis. Okay, if you are studying MSc courses, you can see that this type of works. So we have given some measures of association, and some definitions we have given for, and we have proposed some weaker condition results, theorems, etc. and so on. Okay, I am giving the information only for for the what is that, understand, to motivate you. Okay, that is the idea. You can do this type of activities if you going to MSc or research, etc. Okay, so there are a number of opportunities available. We should have some strong mathematics background. We should have strong mathematical ability. Then only we can work on this type of areas. Okay, at the same time, you can see that this work has very important application in statistics, especially in reliability theory, for computing the bounds for the reliability of series system and parallel system. And you can keep in mind that in computing reliability of multi-stage systems, the bounds for the reliability is still remains unsolved. So you can think about that also in future, at least in future. Okay, so this was the the summary of that paper is given in this what is that, pages. Okay, actually this book is written by Barlow and Proston, and one of the author of this, two authors are no, one of the author is Proston. Okay, so this book is, as I mentioned, this book is based on this type of research articles. Okay, so if you are interested, you can refer that paper also. Okay.